Hello viewers. Today it's not about solution of any question but explanation of terms used in mathematics. In mathematics there are different terms, concepts used, and the understanding of this concept is your work to a very great extent anytime you want to solve any question. Now, what I tag to this lesson is what I call know their differences. Know their differences. Oftentimes, these three words usually confuse students and other mathematicians in being able to tell their differences apart. We have expressions and we have functions and then we have equations. Now, what I say about them is that real mathematicians know hows and whys. Real mathematicians know what? Hows and whys. Hows in probably the steps that you took in solving a particular questions. And whys are sometimes some of the things you say, what is the reason for taking this step? What is the reason for doing this? What is the reason for doing this? If you know how to, but you don't know why it is, you're not a real mathematician yet. Okay, so let's delve into the explanation of this concept. So we say know their differences. The first one is expression, the second one is a function, and then the third one is equations. So I beg your pardon, I try to switch position between equations and function a little so that I can take one. I want them to be a stepwise concept. So these are expressions and these are examples of expressions. First expression is 3x plus 5. Second one is 119a minus 4. The third one is x squared minus 11. And this one is 3x squared plus 5x minus 2, etc. Now, there are so many expressions, as many as possible, that you can even think of. For these ones, 3x plus 5 is just a linear expression because it's an expression of what? The first degree. That's a topic for another day. This is another linear expression, 119a minus 4. That's another linear expression. The variable here is a, the variable here is x. And this is a quadratic expression, x squared minus 11. This is a quadratic expression, 3x squared plus 5x minus 2. These two are quadratic expressions. The only difference is that this is a binomial expression while this one is what? A trinomial expression. Now, moving on to equations, we have 3x plus 5. Same one. This time around is being equated to a number, which is 0. 119a minus 4. Same expression turned to what? An equation. Thirdly, we have x squared minus 11. Same expression is being turned to what? An equation now. And then here I'm having 3x squared plus 5x minus 2 equals 0. Also an expression that has been turned to what? An equation. I can sense that with this, just these two alone, you are beginning to see some kind of differences between an expression and an equation. Then moving on to a function. Oftentimes, especially when you get to the university, or starting from even SS2 in your further mathematics in the secondary school, you see something like this. Y, then a bracket in front of it with the x. This actually means y is a function of x. Y is a function of x, and the function that is describing this y being a function of x is what? 3x plus 5. Same expression turned to an equation and now to a function. So y of x equals what? 3x plus 5. And in this case, the variable is a. So y of a equals what? 119a minus 4. Same expression, equation, and a function. Now, this says y is a function of x. This one says y is a function of a. We say y is the dependent variable, x is the independent variable here. Here we say y is the dependent variable, a is the what? Independent variable. Because of course y is depending on a to have its own value. Whatever value you assign to a here, that determines the value of y. For example, if you say a is going to be 1, 119 times 1 is 119. 119 minus 4 is going to give you 115. So when a is equals to 1, y will be equals to what? 115. That's y of 1 is 115. And if you so put 2 or 3, if you put 3 in the place of a, that's going to be 3 multiplied by 119. I think that should give us 357. 357 minus 4 is going to give us 353. So when a is equals to 3, y is going to be equals to what? 353 in this situation. But in most cases, they used to write it like this: y of x equals to this. You just see something simply written as y equals to 3x plus 5. This y is equals to 3x plus 5. It's still what? A function. It means that y is a function of x. Only that instead of writing it where the function of x, you summarily write it as y equals to this. And the same thing applicable to this. So it can be written as what? 1 over y equals to 119a minus 4. Coming on to the other side, I just try to complete it. That's to tell you that it is not only y that they can use as the independent variable. Other letters can be used, of course. In most cases, they use what? F. If they don't use f, they use what? They use y. And they can even extend it to what? Other letters as well. So, and that's why we have what? G of x is a function of this what? G is a function of x, and the function that is describing g is what? 3x squared plus 5x minus 2. So these two are quadratic functions. These two are linear function. This is a quadratic equation, of course, in SS1 and in SS2. This is a quadratic equation, and these two are what? Linear equations. This is a quadratic expression, this is a quadratic expression, this is a linear expression, this is a linear expression. So what are expressions, what are equations, what are functions? Expressions, equations, and functions all together, they are combination of numbers, variables, and mathematical operators. Three key things they have in common: numbers. In the case of expression, equation, and a function, we have variables, and then we have mathematical operators. Sometimes they will just write them as what? Operators. Mathematical operators. So what are the mathematical operators we are talking about here? We have the plus sign, the minus sign, we have the multiplication, and we have the what? Division. The addition, the subtraction, the multiplication of what, and then the what? Division. So those are mathematical operators. Even squares and square roots and the likes, they are also what? Mathematical what? Operators. Now, numbers are your real numbers: 0, 1, 2, 3, 4, 5, 6, 7, and so on and so forth. -5, -3, -2, 1 over 2, 4 over 5, as many as you can talk about. Now, what are variables? Variables are letters that are used in combination with numbers to form what? An entity. All right. Now 3 here is a number, as it has been told. X here is the variable because it is the letter standing alongside a number. Then this 5 here is also what? A number. So you can see in this expression we have a number, we have a variable, we have the operator. Sorry, the numbers, the variable, and then what? The operator. The operator in that situation, in that case, what? Is the plus sign. Here also we have the numbers, we have the variable, then we have the operator. We have the numbers, as you can see it, which is 2 here. But of course, this time around, this 2 is not serving as what? As a number on its own. It is serving what? As a mathematical operator. Remember when I mentioned the mathematical operator, I mentioned the squares, the cubes, the square roots, the cube roots, and the likes, so on and so forth. So that 2 is serving the purpose of an operator here. So we have the number beside x, even though it looks invisible, there's a number beside it. We have the mathematical operator, which is minus, and then we have another number, which is what? 11. So we have the numbers 3, 5, and what? -2, or 2 rather. And then we have the variable. The variable is x. Then we have the operator square, plus, and what? And minus. Now, these numbers, they have names depending on whatever position they occupy in either an expression or an equation or a function. This number is standing with the letter, so this number is called the coefficient of this variable, of this letter. It means that the coefficient of x is what? Is 3. But when you look at this number, it is not carrying any letter with it, it's standing on its own. So this number is called constant. It is called constant. When you have an equation or an expression or a function, the one that is standing alone without any letter attached to it is called a constant. So this is a variable, and this one is what? A constant. This is a variable, this one is a constant. The variable here, the number beside x squared here, is not visible, but it is assumed to be what? 1. Because it is when you multiply 1 by x squared that it gives you what? X squared. Don't think it's going to be 0, because the moment you say it's going to be 0, then this x squared wouldn't have been there in the first instance. that would have been 0 times s squared, and it would have what? Nullified this s squared, leaving you with only negative 11. So the coefficient of x squared is what? Is 1. And then here, sorry, the constant is what? 11. Here, the coefficient of s squared is 3. The coefficient of x is 5. The constant is negative 2. Same thing applicable to expression, the same thing is applicable to the what? Equations, and the same rule is applicable to what? To the functions. But of course, like I said, the expression, the equation, the function, they are a combination of what? 3 key things. What are they? The numbers, that's number 1. Then number 2, we have the variables. Then number 3, we have the what? Mathematical what? Operators. And these 3 combine together to form what? An entity. They come together to form an entity. This is an entity in the expression family. This is an entity in the equation family. This is an entity in the function family. So what tells an expression apart from what? An equation? An expression does not carry an equal sign. An equation carries an equal sign, but it's been equated to maybe one expression to another expression, or one expression to what? A number. So you can see that's why the equations are equated to what? Numbers. In the case of a function, it is not equated to a number. Rather, it is equated to what? Another letter, which in most cases is going to be different from the variable that you are using. So this one that is being equated to, we call it what? The dependent variable. And the one that explains it or defines this dependent variable are the what? Independent variable. So briefly, you can see the difference between an expression, an equation, and a function. It's a very important concept in mathematics. Thank you.